Okay, so we are looking at problem set 44, right? Let's make that a little thicker. And we're looking at number 24, the word problem. Alright, and that's at revolutions per minute. So he's cutting with table saw. So the saw is a circle, right? Table saw is a circle. You knew that, right? And it goes around in circles. So it's rotating at a rate of 300 revolutions per minute. 300 revolutions. I'll do it like this. Now you could put RPMs, but mathematically it's a little bit nicer if you do it like this. Revolutions per minute. Now when he did the conversion, when he did all these different conversions, remember he went from like minutes to seconds to miles per hour. Remember that? He went to miles per hour eventually. When he first did it, he did it this real crazy way. I'm like, they're never going to understand what he's doing. But eventually, I think when I went to one of those practice problems that he did, he actually started doing it the way that I was going to teach you. So I'll kind of show you that way. Anyway, let's see this. So revolutions per minute, and the radius is 6 inches. What's the linear speed in feet per second? Okay, so we're not putting it in miles per hour, are we? So we're putting in feet. Let's do it like this. Let's go feet per second, which might make it just a little bit easier for us. So we'll put velocity equals, I'll put question mark, and then I'll put in feet per second. Okay? Okay, so what's the linear speed in feet per second of one of the teeth of the saw? Alright, so basically one of the teeth just means at one point, you know, it's going around like this. And so what is the linear speed? So it's like it's going around in a circle, but what if you stretched it out? How fast would it go if you stretched it out and it just went straight? That's kind of what they're asking. Does that make sense? Alright, so let's see, revolutions per minute. So if you go around a circle one time, right, and I got a circle thingy here. Let's correct. Where's my... Oh, there we go. You gotta hold it. Sorry. Okay, so here's your circle, right? And you've got a point. Let's change colors of this. Let's say you got a point right here. That's one of the teeth, right, of the saw, and it's going around here. And the revolutions mean it goes around the circle one time. Okay, so what's it do? It goes 300 times in 1 minute, or in 60 seconds, right? Because we're going to eventually change it to seconds. All right, so you can think of that. So, do you remember the thing about the radians? Did that make any sense to you? Because I was thinking I'll probably have to go through that a little bit with you. Okay, changing it from degrees to radians. Did you watch that one?
Yeah.
Okay. So if you go all the way around, do you remember how many radians is all the way around? Well, halfway around is pi. Right, all the way around is 2 pi. Okay, so what we're going to do is we're going to take 300 revolutions per minute. Let me see the best way to do this. I'll put revolutions per minute. Now what we're going to do is we're going to change that to radians. So 1 revolution is 2 pi. 2 revolutions would be 2 times 2 pi, right? 10 revolutions would be 10 times 2 pi. 300 revolutions would be what? 300 times 2 pi. Do you see that? So what we're going to do is we're changing it into radians. We want to change it from revolutions into radians. So we multiply it by 2 pi. Does that make any sense? And we'll talk about what a radian is. I mean, he explained it, but sometimes he did get a little bit confusing. I'm a little bit more simple than he is, I think. So maybe I can explain it maybe a little bit better for you. So we multiply by 2 pi. Now, do you remember what the formula for velocity is? He wrote it down. Let's do it like this. This is kind of like a famous, I guess, formula. Distance equals rate times time. Okay, that's kind of a actually, do I want to do that? Yeah, that's what I want to do. Okay, so distance equals rate times time. Actually, let me see something for a second. So I'm looking at page 418, and there's a paragraph. It's the very last paragraph, okay, before they start with the problems. and it says generally to convert angular speed to linear speed. That's what we're trying to do right here, isn't it? This is angular speed, and we're trying to convert it to linear speed, which we'll call v. Just figure out how far the point travels around the circle each minute or second. And so that's what we're doing right here. If I take this, I've converted from revolutions to radians, and if I take that and multiply it by the radius of this circle, okay? So, oops, what did I just do? If I convert that, here's the center of the circle, and this is the radius of the circle, and they tell me the radius of this particular circle, don't they? What is it? It's 6 inches, right? So this thing's going around, that's the radius. So what do? I take the revolutions per minute, multiply it by 2 pi to change it into radians, and then I multiply it by 6. Why do I multiply it by 6? Because what's a radian? And this is what maybe I'll explain a little bit later, but I'll just do a quick explanation here. A radian is if I take that radius and I wrap it around the circle, okay, that's how many radians are in here. So if I wrapped it around here, that'd be, I'm just approximating, that would be about 1 radian. You see what I'm doing? It's like a piece of string. Think of this. I stretch a piece of string out here to get the radius. Then I take it and I wrap it around the circle. I actually do this in class. I have a cardboard circle and a piece of string and all that kind of stuff, and I actually do this. Just didn't bring it with me today. So I wrap it around here. That's 1 radius. You follow me? So that distance wrapped around the circle, going around that curve, is 1 radius. And then if I wrap it again, that would go about, I don't know, I'm just estimating, that would be 2 radius, wouldn't it? Or 2 radii. And then if I wrap it around again, it would be about right here, and that would be 3 radius. Do you see that? I'll make these dots bigger. So that distance is 1 radius, that distance is a 2nd radius, and that distance is a 3rd radius. But is that halfway around the circle? It's not, is it? We still got a little bit more. So I've got 1 radius, 2 radii, 3 radii, and a little bit more. What number are you very familiar with when you deal with circles that's 3 and just a little bit more? 3.14. What is that? That's pi, isn't it? Okay, so that's kind of how we get pi. That's 1 radius, that's 2, that's 3, and then a little bit more. Okay, it's not 1 complete radius, is it? It's just a tiny portion of the radius. That's the 0.14. Does that make any sense? So that would be 1 radius, that would be 2 radius, that would be 3 radius, and this little bit, it's probably not very accurate, but that little bit right there is 0.14 of the radius. You got it? So that would be what? That would be pi radians. Do you see that? So that's pi radians. And if you do it again all the way around to here, what do we get right here? We get 2 pi radians. So what we're trying to do is we're trying to find the distance around this whole entire thing, right? And so that would be, it goes 300 revolutions, or how many times does it spin in a minute, right? I shouldn't say that. How far does it spin in a minute? Okay, so that would be pi, that would be 2 pi, but how would I find the actual distance? Well, I'd have to multiply by this radius. Are you watching? This is 6 inches right here. Do you agree? This is another 6 inches. This is another 6 inches, and this is what? 0.14 times 6 inches. So that is pi times 6 inches, that distance around. Do you see that? And if I go all the way around here, that's another pi. So what is that? What is 1 revolution? How far did it travel? If I took that circle and I cut it, and it was a string, right? And I measured out the length of that string, how far would that be? Well, 1 revolution would be 2 pi times the 6. Do you see it? Because that's 1 pi, 2 pi. I'm sorry, this is 1 times 6, 2 times 6, 3 times 6, just a little bit times 6. Then I got another times 6, another times 6, and another times 6, and then a little bit. So what is it? It's 2 pi times 6. If we do that 300 times, do you see that? There's 300 times the 2 pi times what? 6 inches. Okay? So that's how we get that number right there. But we have to convert it though, because that would be the distance. Remember, we took out revolutions, and now we found out how many inches we had. See, by changing it like this, we figured out how many inches. If we took that circle, we spread it out, right? We stretched it out like this. So if I took that circle and I stretched it out, what's the length of that string, if I wrapped a string around this thing, it would be 2 pi times 6, whatever that is. Okay? Then, if you do it 300 times, then you take that 2 pi times 6, multiply it by 300, and you've got the whole entire length if you went 300 times. Does that make sense? So it's like you go around one time, that's this length. You go around a second time, it's this length. You go around 300 times, super big, long length. You get it? Okay, so that actually tells you how far it's gone around. See, this thing's whipping around 300 times. Okay, how far, linearly, how far did it go? It went 300 times 2 pi times 6. All right, and let's plug those in. All right, so let's put this in a calculator. Now we've got, first of all, let's make sure we're in radians. All right, now I've got it in degrees because a lot of times I work in degrees. Hit that, hit enter, see how it's now on there. Now we can do this. So it's 300 times 2 pi, 2, and then pi is right here. Whoops, I lied. Pi is right here. Okay, I just missed it. Okay, so it's times 2 pi times what? Times 6. All right, and there you go. That's how many inches, if that saw goes around 300 times, okay, that's how many inches. If I stretched it out, are you getting what I'm trying to say? If I stretched it out, that's how many inches it would have traveled. Think of this. Think of a wheel, and it's moving, and it makes a mark on the ground, right? So every time it moves one time, it makes a certain distance, doesn't it? Okay? And if it moves a second time, a second revolution, it makes that same distance again, right? Then again and again and again. Okay? Think of it doing that. All right? No, you're looking confused. Are you understanding? And then we would convert it to feet per second. All right? Because this is inches per minute, isn't it? So we'll convert it to yeah. So let's put that number in there. What is it? 11,309. We'll say 11,310. Is that all right? Just to, do they say to round it to anything? Round it 2 places. So let's go 2 places. Oops, what just happened? There it goes. So 7.3, right? So can you remember that number? Because it'll shut off as soon as I start writing. It's 11,309.73. 11. I forget it already. See, my memory's terrible. Can you imagine? Good thing you're not as old as me. All right, so that's what? That's how many inches that traveled in 300 revolutions. Does that make sense? But we want to figure out that's inches per what? Minute. Right? You see that? Because that's per minute. So what I want to do is I want to change it to feet per second. So let me show you how I do this. We have these things called unit multipliers. And this is how I always explain it. You want to get rid of inches and change it to feet, don't you? So if inches is on the top, I want it to cancel out with inches, so I'm going to put inches on the bottom. See what happens there? So when I multiply these together, the inches will cancel out, and then I'm going to convert it to feet. Now what I can do is this. How many feet actually equal how many inches?
12 feet. 1 foot.
Right, 1 foot equals 12 inches. Now look what I did in the yellow. The reason I put in the yellow because I wanted to stand out a little bit. 1 foot is the same exact thing as 12 inches, isn't it? All right. So anytime I divide something by itself, for instance, I'll just pick some random number 3. If I take 3 divided by 3, what do I get? It's 1. What if I take 17 divided by 17? What do I get? 1. What is 1 foot divided by 12 inches? It's just 1. It's not 1 foot. It's not 1 inch. It's just the number 1. Right? And I'm allowed to multiply anything by 1, can't I? Does it change the value of it at all? No. So that's called a unit multiplier. Okay, I think that's very, very helpful. And he does talk about that in one of the examples. He doesn't do it in the lesson that he taught, but one of those practice problem things, he does talk about this. Okay, so watch what happens. The coolest thing about this is this. Watch. The inches cancels out. Now I'm left with feet. But do I want feet per minute? No. I want feet per second. So I got to change minutes to seconds. Now look where the minutes are. The minutes are on the bottom. So I want it to cancel out with minutes. So where am I going to put the minutes over here? On the top. Does that make sense? So that way the minutes will cancel out. And now we can change it to seconds. And you know how many minutes equals how many seconds. 1 minute equals what? 60 seconds. Look what happens to the minutes. The minutes cancel. Excuse me. Now look what I'm left with. I'm left with feet per second. Does that make sense? So now I've got this number. I've got 11,309.73. And to tell you the truth, if you wanted to, now he does this. Again, it's funny because when he teaches it, he always sticks stuff in a calculator and gets decimals. But then when he does the practice problem and he shows you actually do it, he doesn't do that. He'll do this, which I like. I like the way he does the practice problems better. He took 300 because this way you can just plug everything into the calculator all in one shot. You don't have to plug it in, get an answer, and then plug that in again and get an answer. Okay, you plug it in all in one shot. Do you see that? That's that 11,309.73, isn't it? So what are we doing here? Multiplying it by 1, which isn't really doing anything, is it? And then what do we do here? Divide by 12 times what? 60. So that right there, that's what I would rather do. If it was me, I'd rather put all this stuff like this, and this is our linear velocity. Then I would rather put all this in my calculator all in one shot, wouldn't you? Well, I've already done this, right? 300 times 2 pi times 6. And what do? We divide it by 12 times 60. And then we get that answer. So 15 point, and it's two places, right? 71, 15.71. 15.71 is our velocity. Make sure you put the units there. What was that? It was inches, or sorry, it was started off, right, it's feet per second. Okay? Does that make sense? Now look, they don't ask you to do this, but I'm going to do this because they may ask you to change it to miles per hour at some point. Alright, so let's do that. In fact, let's do this. Let's do 300, right, times 2 pi times 6, okay, and then, remember we had all this stuff? Let's write all this stuff right down here again. Let's just copy and paste it. And let's just make it blue so it all looks the same. Okay. So that's what we had, right? We threw that in our calculator and we got it. But let's keep going. I don't want to just change it to feet per second. Let's change it to what? Miles per hour. So let's change feet to miles. So feet is on the top. Where are we going to put it? On the bottom. So we're going to put feet on the bottom. That's right. Equals 1 mile. Did you know that number already? That 1 mile is 5,280 feet. Does that make sense? So look what happens. The feet cancels. Now I've got miles, don't I? But now I got to change it from seconds to what?
Hours.
To hours. So I've got, actually, you know what you could have done? You could have just gone directly, actually, you got to do this. You could have gone from, we could have just done it right here. If we're going to go to miles per hour, right? How many minutes equals how many hours? So 60 minutes, right? You could have done it right there. See that? 60 minutes equals 1 hour. So look what we did. We canceled out. We've got hours now, right? Because we got rid of the minutes, right? Did I do that right? Oh, goodness gracious. Let me go back to where I was because I think I'm leaving too much stuff out. All right, that's what it was. I forgot that was per minute, so that cancels out, and that is 60 seconds. But I could have, yeah, I could have just done minutes to hours. That'd probably be the best way to go, wouldn't it? So minutes is on the bottom. We put minutes on the top, and we put hours on the bottom, and so there's 60 minutes in 1 hour, and there we go. So I don't have to worry about that right there, do I? So now we've changed it to what? And the minutes canceled, right? And now, right, we've got miles per what? Per hour. So if I wanted to figure out how fast it's going in miles per hour, what would I do? I'd multiply all that stuff on the top. I've got 300. I've got 2 pi. I've got 6. And I've got 60. Okay, that's all on top. What's on the bottom? Yeah, well, I've got a 12 first, right? And then a 5,280. Now it looks kind of messy, but I like this way much better than, you know, plugging this in, then dividing by 12, getting a decimal, and then multiplying by this and get a decimal. That's kind of how he taught it at first. But eventually, when he did the practice problems, he actually went and did something like this. And I kind of like this because now you're just chucking all this into the calculator all in one shot. Okay? And I just think that's a little bit better. All right. Sorry for the confusion on that one, but I think that's... Look, I could have actually shown you how to do this problem in about 2 seconds. But I wanted to give you some explanation so when you looked at it, you know why you're doing what you're doing. So really, what is the whole idea behind this problem? You just take the revolutions per minute, multiply it by 2 pi, multiply it by the radius. Okay? Then once you get that number, then you can convert it into whatever they want your answer to be, whether it's feet per second, miles per hour, or whatever they ask for. Okay? But that's the big part of the problem. Okay? That's actually getting your answer. The rest of it is just converting it, right, from whatever they give you to whatever it's supposed to be. Sorry, it took 20 minutes to do that one stupid problem. But I just think it needed some help. Let me show you this thing that I made right here. Do you mind? So let's go back to this. This is the unit circle. Remember I said we were going to talk about the unit circle? Watch this thing. Yes, he did. And, right, I told you last time we met that it was a pretty important thing, wasn't it? And I knew he would talk about it quite a bit. So some of this stuff's cut off on the video, but that's okay. You can see it up here now. Let me show you what I just did right there. Right now I'm at 45 degrees. I tried to get this so I could get the angle to show up right here, but I just never could figure out how to do it. But the angle shows up right here, and this is called a slider. This is a cool thing about this thing I just kind of discovered. Oops, I gotta click on that. This is something that I discovered just by looking on YouTube. And look what it does. Is I change the angle. See that? See how the angle changes? Then that triangle changes, and it goes all around here like this, all the way to 360. So I went from 0 to 360. All right, let's go to let's just go to 45 again, if I can find it. Why is it not going there? Come on, there it is. Okay, 45 degrees. Now, they don't give you the exact square root numbers. They give it as a decimal. But if you put that into a calculator, that's actually the square root of 2 over 2. So let's put that in a calculator just to show you. So it's the square root of 2 divided by 2. And there it is. See, it's 0.707. I just had it rounded 2 places, so it's 0.71. So that's what? Square root of 2 over 2. All right. Remember last time we met, we said you should have some of those memorized. So 45 degrees, you should have the cosine and sine memorized. Remember what the first one was? And look, if I hover over it, it actually kind of tells you what the first one is. What's the first number in the ordered pair? It's the what? It's the cosine. What's the second number in the ordered pair? It's the sine. Now, he went through a big, long explanation of why it is the cosine, why it's the sine. And I'll just leave it at that. But as far as just knowing it, the first one's the cosine, the second one's the sine. And so it's really important, I think, that you kind of visualize this unit circle. Now, we only memorize certain ones. Like if I went to, you know, looks like it's only going in increments of 5s. If I said 55 degrees, that's not one of the ones that I memorized, okay? So I wouldn't worry about that. But which ones should we memorize? Well, we should memorize right on the axis. So right here. And the 0, 90, 180, 270, and 360, okay? And the 45, the 30, the 60, okay, and all those. So I don't think I talked about this one last time. But what if it's 0 degrees? This is 0 degrees. And he talked about this. You start at 0 degrees and you go counterclockwise and you move up. So this would be 0. That would be 30 right there. Okay. There's your 45 right there. And there's your 60. And then there's your 90. Okay. You follow how it goes? And then it just keeps on going, doesn't it? It just keeps getting bigger and bigger. See how the angle gets bigger? You get to there, it's 180. You get all the way down to here. That's 270. And then you go back to where you started, and that's a full circle, which is 360 degrees. Make sense? Mm-hmm. All right. So let's go back to 0 again. It doesn't even make a triangle, does it? So really, the hypotenuse of that triangle, see how it gets, when it gets a little bit bigger, see how the hypotenuse doesn't change, does it? Remember what it was from here to here? What did we make that?
1.
It's a 1, right, because it's a unit circle, unit meaning 1. See how that length right there, it doesn't change. I don't know if I can move. Nah, I have to move it with a slider. Watch. See, that doesn't change at all, does it? Yeah, it just goes around. That's all it does. Okay? Yeah, it is very similar to that. Absolutely. Okay, so that's 0 degrees right there, but the length of it is still 1, isn't it? Because it goes from the origin, 0, 0, to 1, 0. So the length of that is 1, right? What's the cosine of it? Well, again, if you just look at the ordered pair, which one is the cosine? The first one. So what's the cosine of 0 degrees? It's 1, all right? And what's the sine of 0 degrees? It's 0. Now, could you figure out what the tangent was? The tangent is the opposite over the adjacent, isn't it? Okay, so if this is my angle right here, the opposite would be this one, which is the y, or the sine, and this would be the adjacent, which is the x, or the cosine. So tangent is actually the sine over the cosine. Okay, so let's go back to the 0 degrees. So what's the sine then at 0 degrees? It's 0. Okay, and what's the cosine? It's 1. So what is the sine over the cosine? 0 over 1. What's 0 divided by 1? It's 0, right? Now we've got to be careful with this because I'm going to show you something else. 0 over 1 is 0, right? So if I asked you, okay, what is the sine of 0? What are you doing? If you don't have a calculator with you, right, what are you envisioning? You close your eyes, you look at that unit circle. Okay, if I said, what is the sine of 0? What are you thinking? You're thinking, in your head, you're thinking, oh, 0 degrees is right here. Okay, what's the sine? It's the second point, right? It's the x and y. So that point is 1, 0. So what's the sine? It's 0. What's the cosine? It's 1. Okay, what's the tangent? Well, it's the sine over the cosine. It's 0 divided by 1, which is 0, right? And you can always test those right here. What do we say? The sine of 0 should be what?
0.
There it is. Okay, and what do we say the cosine of 0 should be? There it is. What do we say the tangent of 0 is?
0.
There it is. So it works, doesn't it? But it's kind of nice, not, you know, if you didn't have a calculator, you can kind of envision, right, this unit circle, and you can figure out what it is there. Does that make sense? Let's jump up to 90. If I can. It's very sensitive. There we go. Okay. So 90 degrees is right here. Now, just looking at this, without using a calculator, what's the cosine at 90 degrees? It's 0. What's the sine at 90 degrees? It's 1, right? Because the first one's the cosine, the second one's the sine. And you can remember that very easily because cosine, it's in alphabetical order, right? Cosine C comes before S, so you can remember which one goes first. What about the tangent of 90 degrees? Would it be 0 over 1? It'd be 1 over 0. It's the sine over the cosine. It's y over x. So it's y over x. It's 1 divided by 0. What is 1 divided by 0? What is it? Good question. Let's see it. 1 divided by 0. Ooh, didn't like that, did it? Alright, did I punch something in wrong? Nope. And it even tells you what you did wrong. You divided by 0. You're not allowed to divide by 0. Okay? I think we might have talked about that at some point before. Alright, you cannot divide by 0. So, we say that the tangent of 90 degrees doesn't even exist. It's undefined. Alright? So, we'll talk about that, I'm sure, later on, because we're going to graph a tangent function. Remember, he did that towards the end. He graphed a cosine. Remember, it was kind of wavy like that. He graphed a sine function. Then he did the cosine function. He hasn't done tangent yet. Tangent looks a lot different, but that's where this undefined thing comes into place. Do you remember asymptotes? You know, where the curve couldn't hit a certain point. Well, a tangent has an asymptote, and where do you think one of the asymptotes is? It's at 90 degrees, because you cannot have a tangent at 90 degrees. It doesn't exist at all. Okay, so that would be one of your asymptotes. We're getting ahead of ourselves. Okay, but that'll be further ahead. Let's go to 180. What's the cosine of 180? Right? And what's the sine of 180? 0. Right. What's the tangent of 180? 0. How'd you get 0? 0 over negative 1. Right. 0 divided by anything. Doesn't matter if it's negative or positive. 0 divided by anything is always 0. Okay? Except for 0. 0 divided by 0, I think, they just consider undefined. Okay? So that's kind of nice. So let's go to 270. 270 right here. Just looking at this circle, what's the cosine of 270? What's the sine of 270? -1. What's the tangent of 270? There isn't one. It's undefined is what we would normally say, okay, or it does not exist, okay? Most of the time we would say it's undefined. Make sense? All right? And we go back to 360, and that's the same spot as 0, isn't it? So it's the same thing. Cosine of 360 is 1, the sine of 360 is 0, and the tangent of 360 is 0. Does that make sense? So this is really, really helpful, especially if you do go on to higher math or anything like that. It really does come in handy to have a lot of these things memorized. Okay, which one is which? Let's go to 30 degrees right there. So let's go to 30 degrees. Now, what's the cosine? Now, these are decimals, but we're going to remember them as exact numbers with the square roots and all that kind of stuff, okay? And after a while, you'll kind of recognize like which decimal is which square root. Remember that 0.71 we did? That was the square root of 2 over 2. After a while, you kind of recognize that square root of 2 over 2 is 0.71, okay? So on this one right here, what is the cosine? This is 30 degrees again. What's the cosine of 30 degrees? Well, you look at your ordered pair. The cosine is this one. That's the longer segment, and this is the shorter one. So the longer one is, do you remember what that number was? We talked about it last time we met. I'll write them down. The cosine of 30 degrees is the square root of 3 over 2. Okay? So if you either watch last time's video or if you took notes on it, we went through that whole idea of how we got it. Remember we did that triangle and we said, you know, the hypotenuse is twice as big as the shorter side and square root of 3 times the shorter side and all that kind of stuff. So I'm not going to go through that again, but eventually the cosine of 30 you should memorize as the square root of 3 over 2. All right? Let's go back to this. So 0.87 is the square root of 3 over 2. If you don't believe me, let's punch it in. You're probably thinking, I believe you. You don't have to show me. But I'll show you anyway. Watch. The square root of 3, right, over 2 equals, there you go. That's 0.87, isn't it? All right? If you wanted to look at it this way too, watch. What's the cosine of 30 degrees? Remember I said it's the square root of 3 over 2. You should get the same exact answer. Oh my goodness. Oh, you know why I did that? I know why I did that. It's in radians. Very good. I forgot to put, because I'm talking degrees right here. So I got to change that back to degrees. So if you look at an answer and it looks completely ridiculous, you may have to change to the other thing. Let's try it again. Watch this. The cosine. Because what this means what's the cosine of 30 radians? Okay, that's what that's saying. But this says, what's the cosine of 30 degrees? And there it is. It is the same number, isn't it? Okay? Just in case you didn't believe me. All right. What's the sine? The sine's easy. What's the sine of 30 degrees? It's a half, right? Okay, they say 0.5, but that's the same thing as a half. You know that. So watch this. When you have a 30, 60, 90 triangle, the longer leg is always a square root of 3 over 2. The shorter leg is always a half. All right? So what if you went up to 60 degrees? I'm not even going to put it there right now. What would the cosine of 60 degrees be? See, it would go way up here like this, right? So the cosine would actually be the shorter leg, wouldn't it? So what's the cosine of 60 degrees? It's a half, because the shorter leg's a half. What's the sine of 60 degrees? Square root of 3 over 2, because that's the longer leg. Does that make sense? Okay, so let's take this up to 60, and there it is. Sure enough. Look, the cosine's a half, because that's the shorter leg, and the sine is a square root of 3 over 2, because that's the longer leg. Make sense? Now, what about the tangent? It would be the sine over the cosine. So let's do that right here. So let's do the 60 degrees. Yeah, so it's the, remember it's the sine of 60 degrees divided by the what? The cosine of 60 degrees. And what is the sine of 60 degrees? That's the longer side. Remember, 60 degrees is that steeper triangle. Okay, and then the sine is the one that goes up and down. That's the longer leg. So that's the square root of 3 over 2. And what's the cosine of 60 degrees? That's 1/2. Okay, now how do you do that? How do you simplify that? Well, square root of 3 over 2 multiplied by what? The reciprocal. Okay, the 2's cancel. So what's the tangent of? It's the square root of 3. Okay? And sometimes you can memorize that. And we talked about this the last time. Remember what the tangent of 30 degrees is? Good. It's the square root of 3 over 3. And you could do the same thing. You could figure out what the sine of 30 is, it would be the other way, wouldn't it? It'd be a half divided by the square root of 3 over 2, but eventually it would come out to the square root of 3 over 3. So look, 30 is smaller than 60, isn't it? Square root of 3 over 3 is smaller than just the square root of 3. So that's kind of how you can remember those. Does that make sense? The more you work with them, the better it is. Watch this. 45. There we go. 45 degrees. Now, what's the cosine of 45 degrees? Do you remember what that is? What is it? Square root of 2 over 2, right. Okay, square root of 2 over 2, and you're looking at your notes, right? Good. Now, that's good. That's perfect. That's what you want to do. Square root of 2 over 2, and then what's the sine? It's the same exact thing. Why is it the same exact thing? Because it's 45 degrees, and these two legs are exactly the same length. Okay? So that's kind of nice. 45 is kind of nice. Now watch. We can go into the other quadrant. We've just been talking about this first quadrant right here, haven't we? All right? But you can go into the other quadrant as well. Watch this. We already talked about 90. What if I do 120? Now, what is the 120 from? The 120 is from the positive x-axis all the way to here. You see that? That's the 120. But what's this angle inside of here going to be? If this whole thing is 120, what's this little angle right here going to be? It'd be 60, right? Because from here to here would be a whole entire straight line, wouldn't it? Which is 180 degrees. So if from here to here is 120, then this part right here is going to be 60. So this is a 60-degree triangle, isn't it? You see that? So without even looking at this stuff right here, I think I can take that away.
So what would it be, -1/2?
Let me see something. Yeah, there we go. Look at that. Now you can't cheat. Okay. So now, what would the cosine be? It'd be -1/2. Why negative?
Because you're on the other side.
That's right, because you're in the second quadrant, right? This point right here. How do you get to that point? You go negative, then you go positive, don't you? So the cosine would be -1/2, and the sine would be what? Positive square root of 3 over 2. See that? Remember, the longer side is square root of 3 over 2, the shorter side's a half. If you can memorize that, it makes things really, really easy. Does that make sense? Okay. Let's go to 135. There we go. 135 degrees. Now, what angle is this inside of here? If this is 135, remember, we went to 90, and then you went how much further to get to 135? You went 45 degrees, didn't you? So from here to here is 90. From here to here is 45. This is 45. That's right. This is 45, 45, 90, isn't it? All right. So, and we know what the sine and cosine is of a 45, 45, 90. Be negative square root of 2 over 2 and positive square root of 2 over 2. You got it. Okay? What if we went to 150? What's this angle right here if that's 150?
30.
That's 30. Okay, so what's the cosine of 30? Square root of 3 over 2. But since we're in the second quadrant, it's what? It's negative square root of 3 over 2, and it's what? Positive 1/2. You got it. Does that make sense? Let's go down in here. Let's go, what would that be? Let's go, yeah, that's right, 240 would work. So now if we went from here all the way down to here, this bottom one right here, how many degrees is that? This one right here. 270, okay? So that's 270. So what kind of triangle would this be? So if this is 240 degrees, watch, from here all the way to there is 240. This is 30, so that means this angle right here is 60. So this is a 30, 60, 90, right? It's a 60-degree triangle, I'll call it, this angle right here. So what's the cosine? -1/2. What's the sine? But it's negative, right? Because in the third quadrant, it's negative, negative, isn't it? Does that make sense? All right. So all these things I'm showing you, I'm trying to give you a way to visualize it. All these things, these angles that I'm showing you, the 0, 90, 180, 270 should be memorized. 30, 60, you know, and all the other 30 60s in the other quadrants should be memorized, okay? The 45s in this one, this one, this one, and this one should all be memorized, okay? Now, we started talking about radians. We ran out of time today, but we could change these to radians if you wanted to. Now remember, how many radians is that? That's 0 radians right now, isn't it? If you went to there, let's go to here. How many radians would that be right there? Pi. What would it be right here then? It'd be half a pi, wouldn't it? Or pi over 2. Watch this. What would it be right here? How many radians would that be? If this is half a pi, this would be half of the half, which is a quarter, right? That would be a quarter pi. You follow me on that? Okay? So that's the kind of stuff that you'll be doing a little bit later too. I wanted to make sure I went through this unit circle because it's so important, and I really wanted to make sure that you had maybe a little bit better grasp. I don't know if that helped you or not, but it's a pretty cool little program though, isn't it? You can just turn it around and do all that kind of cool stuff. All right, that's it. We'll see you in January, I guess, right? Oh, you're going to take that test and you won't have to you'll do corrections like in a month from now, but that's okay. All right, you guys enjoy your break.